Hello viewers, welcome. In this lesson, we are going to continue the work that we previously started on temperature conversion. Now we have added another temperature scale called the Rankine scale. Now the Rankine scale is also a temperature measurement scale. It's very similar to the Fahrenheit scale. It has an absolute zero of 0 degrees Rankine. Now that corresponds to an absolute zero of negative 459.67 degrees Fahrenheit. Now if we move upwards on the Fahrenheit scale, right from the absolute zero, we will land on 0 degrees Fahrenheit, and that should correspond to 459.67 degrees Rankine. Now the lower fixed point on the Fahrenheit scale is 32 degrees Fahrenheit. So if we add that to the temperature corresponds to 0 degrees Fahrenheit on the Rankine scale, which is 459.67 degrees Rankine, we are going to get 459.67 degrees Rankine. All right, so 491.67 degrees Rankine is the lower fixed point on the Rankine scale. Now it has the same fundamental interval just as the Fahrenheit scale, so which is 180. If we add that to 491.67 degrees Rankine, we are going to get 671.67 degrees Rankine. So very similar. So converting from the Fahrenheit scale to the Rankine scale and vice versa is pretty much straightforward, like converting from the Kelvin scale to the Celsius scale and vice versa. All right, so this is another temperature scale. It's good we introduce it, and then of course we become familiar with it. All right, today what we want to do is that we want to try and get some formulae that we can easily apply in trying to convert temperatures from the Kelvin scale to the Fahrenheit scale and vice versa, and also from the Celsius scale to the Fahrenheit scale and vice versa. So that's what we want to do today. So let us start first by trying to convert from the Celsius scale to the Fahrenheit scale. Okay, so this is the first one we want to do. We want to try and get a formula that we can easily apply. So we start with this. What are we looking for? We are looking for a way that we can easily find the temperature in degrees Fahrenheit if we are given the temperature in degrees Celsius. So degrees Celsius minus the lower fixed point all over the fundamental interval of 100. This should be equal to, now the lower fixed point of the Fahrenheit scale is 32. Remember, so we have that temperature minus the 32 all over the fundamental interval of what? Of 180. Okay, so this is where we are now. So what we have to do now is that we have to try and make degrees Fahrenheit the subject of our equation. So we go there. So we have this. All right, now this is equal to that. All right, okay, so we want this to stand alone, of course. So what do? We try to reduce this fraction, so that gives us this. Of course, this crosses the equal sign, then we have that. Okay, so we have this now. So if we want to convert a temperature from degrees Celsius to Fahrenheit, simply put, the degrees Fahrenheit temperature that we're looking for should be equal to 9 over 5 times the temperature that we are giving degrees Celsius plus 32. All right, I think this is pretty much straightforward. So we come to the next one. We are looking for a way to convert from degrees Fahrenheit to degrees Celsius. Okay, so we have this. Of course, this equals. So now this is the fractional change that we have. Okay, we want to make degrees Celsius the subject of our equation, you know. So we multiply both sides by 100 such that we have this. All right, so we reduce this equation, and then this gives us so this is what we have now. So if we have the temperature in degrees Fahrenheit and we are trying to convert the temperature into degrees Celsius, so what do? Of course, so 5 over 9 in bracket the temperature that we are given in degrees Fahrenheit minus 32 is equal to the temperature that we are looking for in degrees Celsius. I think this is also much straightforward. So we go to the third one, right? So this time around, what are we looking for? We are looking to convert from Kelvin to degrees Fahrenheit. So this is what we are trying to do this time around. We are trying to convert from Kelvin to degrees Fahrenheit. All right. So we are given the temperature in Kelvin. So our lower fixed point here is 273.15. The fundamental interval is of course 100. Now this is equal to this fundamental interval of 180, right? I think this is where we are now. All right. Okay. So what are we looking to do? We want to make degrees Fahrenheit a subject of our equation here. So what do? We multiply both sides by 180, and this is what we have now. So we have this. All right. Equals. All right. So when we reduce this fraction, we are going to get this, right? So K minus 273.15. Of course, we want the degrees Fahrenheit to stand alone. So of course, we either have to add 32 to both sides, or we move the 32, negative 32 to the other side, and then we have this. Of course, so this gives us that. So when we have a temperature in Kelvin and want to convert it into degrees Fahrenheit, simply put, then we apply the formula that we have here. And the last but not the least, assuming we have a temperature in degrees Fahrenheit and want to convert it to Kelvin. So how do we go about that? All right, so we have my fractional change here equals the fractional change on the thermodynamic scale. All right. Okay. So what are we looking to do this time around? Here, what we are trying to do is that we want to make K the subject of our equation. All right. The temperature is in degrees Fahrenheit, and what we want to do is we want to convert the temperature into what? Into Kelvin. All right. So we want to make K the subject of our equation here. That is all that we are trying to do. So we have this. All right. Okay. So all right. Okay. So this is where we are now. This is where we are. So what do we do now? Let us try to reduce this fraction. Okay. And that gives us 5/9, right? Okay. In brackets we have this. Of course, this crosses the equal sign, so that we have plus 273.15 equals K. All right. Okay. So if we have the temperature in degrees Fahrenheit and we want to convert it into Kelvin, all right. So this is the formula that we have to apply. If we have the formula, if we have the temperature in Kelvin, we want to convert into degrees Fahrenheit. This is a formula that we have to apply. You know, we brought about all this all by ourselves. You can see the process. If we have the temperature in degrees Fahrenheit, we want to convert it into degrees Celsius. This is the applicable formula here. And of course, if we have the temperature in degrees Celsius and we want to find the corresponding temperature in degrees Fahrenheit, this is the formula that we have to apply. So with this formula, if you cannot memorize it, of course, you can always do all the process by yourself. You can go through it and then you bring out the formula yourself. All right. So if you can keep it in mind, fine. If you can't, always remember how to go about it, and then you can easily be able to bring out the temperatures all by yourself. I think this is pretty much easy. It's not so difficult. We can always be able to do that. So I think with this, we've come to the end of this short one. Yeah, a very quick one. So we can take a couple of temperatures and we can easily and quickly try to convert. For instance, if we take a temperature, if we are trying to convert a temperature, let's say maybe 40 degrees Celsius, we want to convert into degrees Fahrenheit. You take the 40 degrees Celsius given to you, you replace it in the formula here, and then of course you are going to get your temperature here, which is 104 degrees Fahrenheit. Equally, if you are given a temperature in degrees Fahrenheit, you want to convert to degrees Celsius, assuming you are giving 134 degrees Fahrenheit, you want to convert to degrees Celsius, you only have to put the formula in the equation here, and then of course the solution is going to come out. You're going to get 57 degrees Celsius. Equally, when you are given a temperature in Kelvin, you want to convert to degrees Fahrenheit, the temperature that you are given, you only have to replace it in the formula here. So assuming you are given a temperature, let's say 313.15 degrees Kelvin, you only replace it in the formula, and finally you get a temperature of your 104 degrees Fahrenheit. And last but not the least, if you are given a temperature in degrees Fahrenheit, you want to convert to Kelvin, the formula, the temperature you are given in degrees Fahrenheit, you only replace it in the formula here. You have it here. So you put the temperature in degrees Fahrenheit here, and then you are going to get the temperature in Kelvin like there. So assuming you are given 134.6 degrees Fahrenheit, you want to find the corresponding temperature in Kelvin, you put your 134.6 degrees Fahrenheit in the equation, you compute, and then you are going to get your 330.15 Kelvin. I think that you sit on it, you just work on it gradually, and it's not so difficult. It's pretty much easy. The whole thing explains itself. So with constant practice, I think we can be able to convert temperatures from one scale onto the other. Not so difficult. Remember, the only way that we can become better is constant learning. Let's keep learning, because learning is fun. Let's keep learning. Let's keep on improving and developing ourselves, because knowledge is like a metal. If you don't polish it, it's gonna go rusty. It's gonna go rusty. So no matter how good you are, you constantly have to keep on revising. So it's like metal. You keep on polishing the metal, it shines and becomes brighter. You stop polishing the metal, it goes rusty. Yes. So let's keep learning, because learning is fun. Until I see you in my next video, remember, as always, take care of yourselves and each other.